Great. Good morning, everyone. I think industry leaders who were there on the dais have made my life at least more easier. They've set the right perspective, the context about why we are here in this room. Largely, we're talking about the India power systems, the age and how we are kind of going to do a progress in the overall working. Now look at the way we are kind of diversing on the overall working. We are entering into a new operating reality. Now we see demand is rising. We are talking about having reliable and flexible operations. We are also talking about becoming more complex working. We know that renewables are getting added. What's more important when the industrial growth happens, there is a more complex industrial load is also adding up. Now, in all these aspects, what is more important is to look at how we can actually make a more resilient grid in terms of creating that infrastructure, not only to see that it can manage the overall the changes or the complexity what is coming up with additions. It's more important to see how we can also respond to any events, right? Events are tend to happen, be it cybersecurity events or events pertaining to, as we were speaking about the Rajasthan event. We need to be ready and we need to make ourselves more resilient towards that working. And energy transition is an apt topic which we have to work on. And digitalization part of it, it's no more an IT upgrade projects. It's more towards driving the things towards making the data more visible. I think Chris did mention about in the morning about how the things are unfolding from a data standpoint if you really put those into the right context. One of the key things, I think I and Alok were discussing about the leadership panel, and what's more importantly coming out is how do we really get to have a session wherein we have more collaborative in terms of making these challenges heard from different speakers. And I think that's the whole context of this session. Alok, you would like to invite? Thank
you. Let me introduce the panelists. But to begin with, let me apologize for being delayed. Mr. Kumar was stuck in traffic, and he could come only at about 30 minutes late, so we're somewhat delayed because of that. So my apologies. Those of you who come to our conferences know that we generally stick to the schedule. My particular apologies to the person I'm going to introduce, that's Mr. Srivastava, whose time I'm always very conscious of because he's a very, very busy person. And it's a great pleasure to have him here. I should say Dr. Srivastava now. It says Mr. Srivastava, but I know he has a PhD now. He's Director of Operations at Power Grid Corporation of India. Also now the Chairman of Central Utility as well, just a few weeks ago. I won't talk about the different positions he's held, but I can just tell you the last few years he's really been spearheading the digital transformation that's happening in Power Grid. And there are many areas in which the digital transformation has happened, but in particular, asset management is one area where he has achieved tremendous changes and has also got a lot of recognition. Great pleasure to have him with us. Please join me in welcoming Mr. Srivastava. Also with us is Mr. Pradipta Kumar Mishra, Managing Director, Jindal Power. Mr. Mishra has got about 40 years of experience in the power sector, has earlier worked at NTPC in different capacities, in O&M as well as heading power plants, as well as being Executive Director of Western Region. Please join me in welcoming Mr. Mishra as well. Very happy to have with us from Calcutta. I'm assuming he's in Calcutta. Mr. Brajesh Singh, who is Managing Director Generation. CESC has got about 3.5 decades of experience in thermal power engineering. Led the turnaround of Prayagraj Power Generating Company Limited. Also has worked with NTPC. Please join me in welcoming Mr. Singh. And finally, great pleasure to have our good friend, Mr. Sanil Namboodiripad, who is COO IndiGrid. Mr. Namboodiripad has been involved in transmission for quite some time, has earlier worked at Reliance Power, Sterlite Power, Adani Transmission, also at ONGC Tripura Power Company, where he was a managing director, and great pleasure to have him with us as well. I would like to begin this discussion with question for Mr. Srivastava. And there are three broad sets of questions that we are going to ask. And somewhat different question from Mr. Srivastava than for the others. Each one will have a different question based on what we think we need to ask you. As I mentioned, Mr. Srivastava, you've been spearheading the digital transformation, and what has been achieved so far, and what is it that we can expect to see in the next, couple of years to 3 years?
Very good morning. And first of all, thanks to Powerline Magazine, AVEVA, for inviting me in this forum. Let me start with one thing. Because we are from Power Grid Corporation, we are in the transmission sector. Initially, we used to think that transmission is basically building a tower, conductor, transmission line, substations. Now, the transmission sector is not only left with that. It requires a networking of digital data and automation. Now, the more emphasis on that. Reason is, as we are expanding, Power Grid is having almost 293 number of substations and almost 185,000 circuit kilometers, almost more than 6.3 gigawatt, 630,000 more than that, your MVA capacity. So the way the network is expanding, you cannot maintain it manually. We used to have it. The legacy which we used to have, breaker operations and operation by manual, it is not that. So digitalization is very, very important. Seeing that the lot of data which is coming up, it cannot be held manually possible. So that way we have to see that we have to have a compromise between the aging assets and the new assets which are coming up. All assets has to be digital formations. You have to have a data, you have to have integration between your ERP or your SCADA or I2P, which you are taking inspections data or maintenance data and all. And now, above it, that AI should be to take the decisions based on the data available. Of course, challenges will be there, how data how it is transparent and it is good. So data, if it's we are able to come out of that. So this is a need of today that without digitalization, whether it is a CTU or STUs or any TSPs, we have to go whole of the digitalization, whether it is operational, there is a maintenance, there is a decision making. We have already done 100% operation digitalization. You see that all the substations are operating through digital. Even in maintenance also, to getting the data, we are going with for the transformers, reactors, breakers. We have a platform. We are getting the data. Health indexing is coming up. Now we are trying to, club all these data which is available, inspection which we are doing it now. We are doing with the laptop. It is no more in Power Grid. There is a manual data is being. It is with the iPad and all. They are putting it there itself. They will able to find it out what is the health index and all. So this is very much required. And the way the energy security is there, outage rates to reduce, increase the availability. This is also, it's a very that outage time should come down. So these are the areas. It is only digitalization can help you out. Only AI can help you out. Only your data will help you out. It is now, Power Grid has decided that by 2030-31, we will have at least 60 to 70%. So decisions will be totally AI based. And we are at present, we are at 30 to 35%. All the data which is coming up, we are doing in the AI based.
Okay, I'm going to come back and in the second round ask you for more questions as well. But before I do that, just one follow-up question. In terms of priorities for you, which are related to digitalization over the next, let's say, 2 years, what is the one project that you are most excited about?
We are working on two major projects. which is once is the asset performance management we are coming up,
Right.
where we are going to integrate all the data which is available. So at present, I'm telling you, project management is working at a different platform. They are having their own data and all. Asset management is working in their different platform. Commercial is working on a different platform. My finance, funding and all working in a different platforms. So now we are integrating all that in one, so that we will able to know the aging of the equipments, how much money we have to invest, how the funding we have to do, and how to be operability and the maintenance problem or the project which is going to come, how we can integrate it by feeding the data once, it will be commonly. This is the one area. And second is the cyber security. There we are going in a very large scale. We'll see that best part will come out, and we'll see that we have already made a Power Grid Center of Excellence with ISC Bangalore, where we are already doing around 36 to 37 projects, out of which we have already done POC for 6 projects. Others we are going, and we are investing money for the cyber security.
Okay, thank you. Mr. Singh, if I can come to you next. And my question is somewhat similar, but maybe a bit more specific, which is how is AI and IoT transforming operations for Gencos like yours?
Good morning to all.
If you want to, you can also speak for the CESC ecosystem entirely and not the generation. It's up to you.
Okay. First of all, thank you Powerline AVEVA for organizing such a relevant and the most needed topic. In the morning, already Alok Kumarji has explained the total energy transition and the need of digital. So I'm not going to speak on those topics because it's so elaborative, so wide, and that is need. Particularly for thermal generation, there is a huge increase and acceleration in RE. And one point I want to mention, say, energy transition, we are talking a lot, worldwide is happening, India is happening. We are standing at the intersection of so many variables, so many, not called challenges, we can say opportunities. There is flexibility, there is grid stability, there is reliability, there is affordability, there is, you can say, environment stringent norms. So addressing all this is the one word I can say is operation in commercial correct operation. If you operate commercially correct, it is going to address all your maintainability, affordability, your reliability, safety, and that will achieve through operational excellence. And this operational excellence for the assets, in particular thermal sectors, is having wide variety of the aging. Some are designed with the 60s, some are designed in the 90s. 90 to 2010, almost very slow in the thermal sector. After that, few additions were there. And 2005 onwards, there was huge acceleration for adding the new power units, which are going to be commissioned by 3031, 32, all are the 800 megawatts, supercriticals, ultra supercriticals. So these changes happens to address the AI and ML for particularly power generation side, thermal side. Now to meet the current requirement, thermal generation role is changed. Earlier the plants which are designed for the base load operation, now they are going to operate to support the RE. RE is going to be the prime suppliers. And how to manage the gap, which is in evening peaks, the surges in the day and night with the wide variations, that will be going to be taken care by thermals. Those thermals are designed in the old 60s, 70s technology. 2025 onwards, those it is incorporated in the design stage, how to operate flexible mode, how to operate in two-shift operation. But those machines we are designed in the 80s, 70s, they are not capable of that. But that is a need. As per recent regulation, ramp rate should be 1%, 2%, 3% with a different slab. And that need to be incorporated. And how to address those needs, number one. Number two, by operating the machine in such a way where they are going to impact the life cycle of the components, performance, and also reliability and safety. So these things are not done by simple SCADA automation which are provided in the design stage or with the machines. Now this need to be upgraded with the help of AI and ML so that the intelligent models, self-learning models can provide the risk of the operating the equipments and the units. Number one. Number two, these equipments and units are normally, the designer provided the rate of degradation. These rate of degradation are two types. One is natural degradation and the second is external influence degradation. This natural degradation are designed with the design life, 70% the design life and 20% with the external factors. That is working environment, operation regimes, grid disturbance, all these things. But now in this change scenario, presently which we are operating is entirely changed. Is 60% is external influence. Day and night we are operating machine off design. There are so many wide variability of the parameters. Ramp up, ramp down increases so many excursions. This excursion is consuming the life cycle components. In this condition, how to manage the assets is a challenge. And that will be possible only through use of not only AI and ML, because AI ML is normally based on the words and the pattern. There needs the basic fundamentals of thermodynamic modelings. So these thermodynamic fundamentals need to be redesigned, need to be recalculated, the curves are need to be regenerated to incorporate your day-to-day operation with the help of AI and ML.
Thanks.
Because AI ML will further enhance by the self-learning, the rate of degradation, rate of deterioration, rate of risk, how it is going to take care, how much life cycle consume, what is remaining life, and in this remaining life, how you operate the equipment safe.
Thank you.
So that should be now a strategy.
Thank you. We'll come back in the next round, sir. Okay.
Thank you.
I want to make a number of rounds here and make it more freewheeling and that more interactive. Mr. Mishra, you can answer the same question I asked the others, which is digital transformation, IoT, AI. What is your view on all of that?
Hello. Good morning to everyone.
And specifically, how is this helping your unit?
See, the question is now not whether digitization and AI is required or not.
Right. But how?
Sitting here, if I can monitor what kind of water my parents are drinking at some 2,000 kilometers away in house, that is the thing, self-explanatory, why we need digitization. And it suggests what to be do, when to change my filter, I can do it from here. That itself says why this AI is required. Coming to the industrial front, we listened to Mr. Alok Kumar also in the morning, how AI and digitization going to improve for the discoms and what is the requirement. I give you a different perspective to that. When there is a problem in the country, the international geopolitical situation we all have been seeing since last months, there is a austerity requirement comes from the PM and the government. Don't use don't use your transport, don't go to office, try to minimize the fuel and all those things. Why can't we do it on real-time basis? You see, if you see you don't get the frequency, what it's operating in your house, you only see the power qualities, your lights are on or not, AC is giving the output or not. You never see the frequency, okay? Frequency decides whether the grid is healthy, whether it is nearly 50, it is 49.9 or 50.01, only grid operator sees that and takes action. Then gets worried, as he was telling, the short-term demand forecasting is a big challenge for the discoms. They do not know what kind of load pattern they would be having in next hour. My point is when we are going for digitized and smart metering, you give the other perspective to the consumer also. A pop-up should come immediately. If you reduce your power consumption, you are using right now 5 ACs. If you reduce your power consumption by reducing some ACs, then your incentive will be per unit, you will be getting 2 paisa for this power consumption. Immediately, that will solve. Across the country, we are 140 crore of people and the households, and small bit of contribution by each. If you show this kind of alternative to the consumers, they will never object to your smart metering. They will see some intake also though. So whenever we make some system, it has to be both ways. So this kind of small system also will help. Then also we heard about we have a renewable energy which we are not able to put into the grid because of the transmission constraint and the grid stability. As all you know, more of the solar power gives a lot of instability to grid because it doesn't have the power to pump reactive energy and all those things. So we should find out wherever the energy is available in abundance and we are not able to transmit, how to get some manufacturing, some utility to come down there and use that day energy in a decentralized grid. Maybe we started from decentralized grid and now we are one grid. Maybe in gradual manner, once we are looking at the integration of all this power going forward, how we can also see the decentralization. And this cannot be possible without a digitization of the whole of the things, starting from what you consume or what a generator supply, and in between the transmission, distribution, everyone. If you everyone take into part digitization, and see why AI is important, because you will agree with me, most of our energy down the line, if we or our staff, 70 to 80%, if you say the time goes on data keeping, management and reporting. Hardly 5% of time they use for creativity or do something. So that redundant part should be taken care by digitization AI. When you come to the office, it shows what to do. In a power plant, suppose you plan a maintenance schedule, a conditioning-based maintenance schedule, but it doesn't say that it is always correct. So whenever this AI enablement is there, it will show you based on your 1 year data, these are the maintenance what you have planned today, these 5 are not required. Or these are the 3 things we need to focus. Then it will be more productive. So that is my way of looking at AI, and also why it is important. See, we saw the war previously fought on feet. Army, lot of artilleries. Then it came down, then it came up to the naval base. Then it came to the bombing base from the aircraft. Then came missiles, then came drone. What next? Next kind of war we will be seeing when no such involvement will be there. It will be only cyber war. You trigger something sitting here, devastation will automatically occur. So we have to be prepared. When you are going for digitization AI, this is also important, you should not forget.
Thank you, sir. Mr. Namudrabad, you've been listening very patiently, and I'm sure lots of thoughts are going through your head. So at IndiGrid, I'll ask you about IndiGrid now, not about NIPCO and a bunch of other things you've been involved with. At IndiGrid right now, what are the initiatives you have with respect to digitalization, but also AI and ML, etc.?
Good morning, everyone. IndiGrid owns and operates transmission lines, substations. We have also 1,500 megawatt of solar power plants, and now a couple of battery storage projects. If you look at the digital journey of power sector, earlier the first digital things that we implemented were the turbine controllers, the digital exchanges, and then the digital computerized maintenance management systems. They are still relevant. All of these are still relevant. We do have digital computerized maintenance management systems for all these, the 3 verticals that we have. But what has happened over the years is that the communication networks have improved. So now we are able to connect directly to those equipments at site. For example, an inverter in a solar power plant. If you take a typical 300 megawatt solar power plant, you'll have at least 2,000 inverters there. To get the data from these 2,000 inverters, today it's possible. Multiple data comes from them. So you are able to analyze the performance of that particular inverter, and then you are able to pinpoint where the actions are to be taken to improve the plant performance. Second is the maintenance practices. So from the monitoring to the maintenance practices, if you have your own system of now raising a work order from that damaged inverter, directly the messages go to the maintenance manager. The maintenance manager then can go and work on the inverter, get it rectified, and you can now again look at the loop and see how we can improve the performance of the whole process. So this is where the advantages are coming in. And with so much data, if you look again at a 300 megawatt, say a 300 megawatt hour battery storage system. One container of 5 megawatt hour contains around 5,000 cells. These 5,000 cells give you data of temperature, current, voltage, etc. And these needs to be continuously monitored. Otherwise, you will damage the battery when you are overcharging it or over discharging it. And continuously monitoring that is not possible by any individual. So you need systems above that. The analytics on top of this data gathering is required. And that analytics goes to the the information systems where the engineers at the control room are able to take decisions what to do. So today I'm sure that, like everyone has been saying, digitization is absolutely necessary. It's not a question whether it is required or not. It's only how much we can digitize, how much information you can gather, and how much intelligence you can put on top of that. That is where the debate is today. And I think there are multiple ways of getting it done. There are various standards also, like we deploy various rigorous standards for analyzing the health of the equipment. Like Naveen sir was telling, there are various rigorous standards for analyzing the health of a transformer. So if you have the data in place, you can analyze that and come to conclusions. So this is where we are working on, monitoring as well as maintenance practices.
Thank you. Mr. Jadhav, you are involved in some of the areas. I know you're moderating, but co-moderating, but you're also involved in these areas. Any suggestions that you have for the panel and based on what you're hearing?
Thanks, Alok.
Within 75 seconds, though. Okay.
Yeah, largely, the perspectives what our leaders have put forward. I think from morning we're talking about the data set, bringing the data right from the different data silos, making the data available in the right context. And what is more important is also to see how we can make a data value delivered. So three things which are coming from the overall panel is, are these set of data actually delivering the values? Because every utility, I've been working with utilities from last 24 years, and I'm privileged to have those in this room also. And those utilities have been always have a forward thinking about saying, okay, if we invest something, what is an ROI expected out of it? Are we kind of going in a right path that whether the data, whatever we are collecting today, is going to help us tomorrow? And secondly, very importantly, whether the scaling of these pilots is important. I think, Mr. Dhawan also spoke about it. It's very critically, if you really look at it, right, the pilots are successful always, but when you look at how do we scale them to a larger areas, right, that becomes a challenge. So we will have to really look at it, how we can focus on those set of areas.
Okay. Mr. Sarwat, I'm going to ask you next question, but before that, do you have any comments on what you heard? And then I have some other questions for you.
The comments is very clear. It is everybody panel, you can see that we are in need of digitalization. We have to see that whatever best, there are a lot of generative AIs are available in the AI tools it is available, we are committed. But we see that it is to be incorporated in such a manner, it becomes useful to you. What Alokji was also telling, it should have a specific, security, reliability, and affordability. These are the areas which has to work in that way. So this is my comment on that.
Dr. Srivastava, specifically, what about the role of Gen I and digital twins, et cetera, et cetera? I know that recently there was an experiment in Rajasthan where they simulated that with the use of digital twin, the need for energy consumption will be reduced. I mean, energy input will be reduced, and that therefore the need for energy infrastructure will also be reduced. Anyway, I know that you've done a lot of work in this area, and so would love to have your thoughts.
As far as I can tell about Power Grid is also, we have, in a vast manner, we are using generative AIs. We have made already digital twin for the HVDC systems. We are going for a digital twin for our substations and transformers, and also for the transmission lines. And I tell you, these generative AIs which is available, this is very helpful in, we have got a lot of helpful in our, PG Amrit, where our, patrolling of the transmission lines and all defect identifications. This is very helpful in that. If I say that, digitalization or generative AI, they are basically has become the intelligent partner to us, and they are becomes a very important, support system for decision makings. In the outage rate, root cause analysis, RCA of the equipment's assets. These are the very helpful tools, I'm telling you. We have reduced our maloperations from 5% to 0.6% now. We have reduced the failure rate of transformer by almost 37%. And these generative AIs, we have helpful in RCMs also. That is reliability central maintenance also. We are not going for predictive or, proactive maintenance. We are going reliability central, which is required more attention attentions where these are only AI is telling us these are areas where we have to put more attention there, which we require less attentions and all. Including our management has become very important. You know, our board members, they are sitting together, they are using these tools for the decision making of their investments also. So I'm telling you, these are the very important tools, not only for, you know, for my asset managements, for our transmission lines, for our, you know, operational maintenance, for our project management, for our fundings, for our regulatory frameworks. These all are being, you know, one we are coming up. And I'm sure that in next two to 3 years when APM will come, I'm sure that these all will be on, you know, AI-based decisions we are going to take it. So this is a very clear forum. We have to see that there are a lot of tools are there, but you have to see that how best you use for yourself. It is not that whatever it is coming up and we are as it is we are using it. Make it customized as per your requirements and use it up. So this is very helpful. I'm telling you, this is the next generation's requirement also. If we don't do it right now, we will be late after 2 years. That is my point, sir.
Dr. Srivastava, just one other question for you. How is there's no one here from Grid India, but I'm going to ask you a question about Grid India. How is Grid India or Grid Controller, whatever the new name is, how are they incorporating that into their systems?
Actually, Grid India used to be part of Power Grid. It was shifted, so whatever infrastructure are, it is Power Grids only. But I'm telling you how it is working. Now we have a different systems. We have called the VMS, FMS. We have a, what is the climate systems. What somebody was telling that all of a sudden there was a cloud has come, there was a loss of around 4 gigawatt. This is the area where all come club together. When you go to any, RLDC or NLDC, you will see that these all datas from PMUs, these datas are coming up. They are concentrated on one place, and it is very helpful in taking a decision making. Our energy security has come out in a very large scale by using this, generative AI. Because all the data is available, whether it is a climate data, where it is, at present, what is the generations going on, where it is thermal, grid security point of view, where the voltage profile, what is the frequency profiles. This all data is, when you are available, you can take a decision immediately, and it will really reduces the outage rates. It's helpful in the disaster management also. Whenever there is any grid disruption occurs, it should not islanding in these areas. These are very helpful by using these digitalizations and these AI based. These are bringing together so that the outage rates comes down, and which is affordable, and it should be 100% time it is available to the customer, ultimately for the customers.
Mr. Jadhav, I think you may want to take up the questions about readiness for the other panelists. Yeah.
Yes, I think, largely I think the first question of yours, they have covered, they have summarized everything, but I would like to go in a little detail about a thought process about constructing a resilient grid. I mean, like Mr. Srivastava, if you can just give a little briefing about, it's definitely more complex when it comes, when you're talking about addition of renewables and maintaining such a kind of infrastructure. You explained about APM, you explained about the things. How we are kind of looking at an integrated architecture for your grid?
Of course, when renewable comes, it is affordable, it is coming up. There are coming in the challenges also. I'm telling you, that is basically it is a pocket of Rajasthan or Gujarat. There is a load centers maybe in Delhi, maybe at Telangana or Gujarat area. Long transmission lines are to be made. When the transmission lines comes, large high scale HVDCs are coming up. 765 is coming up. Now we are coming up with the 1200 kV also. 5 number HVDCs are coming up. They are coming up with a lot number of certain challenges as far as grid security is concerned. I'm telling you, initially when thermal generation used to be there, then there was inertia, there was a short circuit level was almost on a comparable level. It was, we are able to, even gas generation used to, consume the reactive power. But when it has come, it is coming up with lot of oscillations. And now when these comes up, we are going for another technologies. We have come with the SVCs, we have come with the STATCOM. Now we are, Power Grid is going to do a pioneer work, bringing the synchronous condensers also. So these are the challenges which is coming up to, reactive load which is coming up to come up. So see that now the grid which we are seeing today, or we have seen around 5 or 6 years back. It will not be in the next 5 years. It will be a different grid. It will have a different challenges. So this is the area when all the integrations comes out. Of course, that's come with the good challenges, but it is really, ultimately is the customer. We have to see that consumer get a reliable and a, affordable power.
Thanks, sir. I think that's one thing summarizes more. We are in a safe hands in terms of managing the grid. Thanks a lot. Mr. Singh and Mr. Mishra, I have a question for you from a generation standpoint. We are also seeing that pressure coming on you in terms of renewable additions, trying to see the flexibilization is coming up in a way where you have to really manage your plant with more efficient and, try to see how those old assets as well as the new assets also come to that particular flexibilization standards. What are your thoughts about, how are you kind of making your plans? Maybe Mr. Rajan, then Mr. Singh.
Yeah. See, you rightly touched, there are two kinds of assets. One is the old assets, which we have to continue, and maybe the new assets which are coming up. Of course, new assets would be definitely coming with flexibilization, but that is the demand. Because right now, we operate up to 55% in the daytime, from 103% to 55%, then again ramping up in the evening. So going forward, the new units would be capable of those requirements. Old units, we try as much as possible to operate at a base load for one unit and another unit, we leave it at that. So internal management we try to do. But the biggest challenge comes, see, we have seen this energy security issue during this war-like situation. It is not the only thing that we generate, we have maximum for coal power, so we are secured. We are not dependent much on the gas and oil other than the peak hour and the transition period. But my point is, what is that producing this coal power, power from the coal? We need machineries. And if you bring it down, the machinery, somewhere we are stuck up. Again, we are dependent on the raw material, on the import. If you talk of transformers, we have still CRGO steel we import. If you take up turbines, we still have the blade material we import. If you talk of boiler, still the tube material we import, even if we manufacture tubes here. So we have to see that kind of resilience, how we can develop in the country, so that we are not dependent on others. Whatever we produce, maybe we are good enough in producing the electricity from coal, but on the raw materials, somewhere we are getting stuck up. So that kind has to be also addressed simultaneously, how to encourage and what the pain points everyone have, whether it is a private sector, government sector or the PSU, everybody has the similar kind of equipments and everybody has the same pain point. So we need some kind of policy advocacy, how to address those 80% required material which requires to be attended and given some attention through policy or R&D so that at least we at some area we say we are self-sufficient. Like solar panels also, we make so much of solar energy. There are manufacturing plants. Somewhere or other, the ingots and wafers we still get from outside. So the downward integration is required where it affects us most. And other than electricity, if you talk me of the energy, we can't produce oil because we do not have gas. What we can do, we can create more storage in the country. So that in the hours where you get abundance, you store for your rainy days, what we learn from the childhood stories. So that kind of thing is required. So in the power plant, we also plan, the way we plan, what is the peak hour, peak demand in the country. We do not take generally any maintenance during those peak time. April, May, June, July, we try to give maximum. So what bothers us during, how to make our units available. And if you still bring it down, the most problematic thing, most issue for me is the boiler tube leakage. Because the high pressure tube fails, then 2 or 3 days it goes out of order, the unit, and you can't contribute to those. So there we need a lot of AI, what we are bringing now. We have a lot of data and failure history throughout the country for different type of boiler and material. Then use the AI technology to predict where we should address during the time so that we have maximized our availability during the period. That kind of intervention we are bringing. So this is my submission on how to make ourselves available and to have to the country. One more point I'll tell from the policy point of view. See, what is paramount in the country has to be given the paramount importance. I will not quote any specific example, but I'll tell one example where the peak hour demand touched 270 gigawatt. Okay. During that time, somewhere in the country, there is 1,000 megawatt remaining to give power to the country, to the grid. But all the policies of state and central, I will not blame anyone, all the policies are framed like that, didn't allow for 1 year at least that 1,000 megawatt to be connected to the grid. So we need that kind of, if it is paramount that we should have energy security, the policy should be first allow the energy rules and all those things can be taken care of later. So that is my request for the policy advocacy side to make it seamless. One question I will have for Mr. Nabeen. He has not touched that, the base pain point, how we face problem during the transmission line construction, the ROW issues, the land related issues, how we can use digitization and AI so that that issue can be addressed. If you can throw light, then we will be happy.
See, I'm telling you, when you make a transmission line, the ROW is basically I'm telling you, 100% or maybe 99%, farmers are ready to give their lands, but at a certain cost. This is the ROW, what should be the cost, and it should go to the genuine person. That, how I'm telling you now, the rate decisions are, you cannot digitalize, you cannot do in that area. There is a manual system. Now we are taking evaluation and all. There we cannot add into that. But where we can add in the digitalization is the data of the, where the transmission line is going in with the LIDARs and with the technology. We know who is the person, who is the, owner, where the transmission line, where the tower is being placed or the transmission line is going. So now the compensation for the tower base as well as for the line corridors has become equally, it becomes very easy to find it out the owner and the land requirement to pay for him. And there is no dispute cases also. This is, I'm telling you, digitalization of land data has played a major role in that. The second part, which is very important, is the in the ROW comes out to be the land which is, the optimization of the route. It should be, see that the minimum persons to be, best transmission line, which is having low corridor to be used. Now we are going for, best, pole type mountain and all, that is of different. But the corridors which is being reduced by using the LIDAR technologies and optimization of the route has really reduced the, ROW cost in that manner also.
So it's quite interesting. I mean, a question again. Thanks, Mr. Srivastava. I think that's more it's important also to see the challenges. While we are solving one problem, there are integrated problems are there. Mr. Singh, I think the question was same for you in terms of flexibilization. I'm sure I've been working with CESC and maybe, the information or your experience of working on those challenges and how you're kind of addressing them will definitely help all of us.
I am from CESC. Those who are not knowing CESC, I am telling a little bit about CESC. It's a more than 100 years old company, RPSG group. And we are having generation and distribution both. Distribution in Calcutta and Kota, Bharatpur, Bikaner, Chandigarh, and Greater Noida. For generation side, we are having the 4 power stations. One is Bajbaz, second is Southern Generating Station, that in Calcutta, then Haldia and Dhariwal. We are having the asset from wide range, 35 years old plant to 10 or 15 years middle age plant. And the most important thing for the operations of these plants are flow of the data. Data should first flow. The authenticity of data is required to make the models so that based on the model, decision can be taken. That should be dynamic, real time. And for that, we have taken a number of initiatives. One is called Conclave. Conclave is basically for performance improvement initiatives, KPI based. That is for normal thermal power plant, the KPI is SHR, APC, DM water, force outage, all these things. So these are the real time. These data are fetched from the station to corporate. We are having the ACOE, Analytics Center of Excellence, and these data are coming through via Pi. Earlier, this was some other software, but later now we have augmented with the Pi. Already team has developed 26, 28 models. That models they are making with the help of AI more intelligent. Second thing, since KPI, a lot of improvement is required to address the performance and the reliability, and that huge investment and expenditure required. That cannot be done in a year. So the second initiative we are taking is the Param Sankalp. Param Sankalp is 6 to 8 years plan. How this expenditure can be distributed to address the risk, reliability, safety, and performance in 6 to 8 years plan. And accordingly, the annual business plan was prepared, and everything is included in your planning. In plan outage, whatever things need to be done for performance side, reliability side, that need to be included in the scope so that the time-based work can be done and the downtime can be reduced. Third thing, the most important is, though there are a number of RCA, number of way of analyzing problems are available, the most important thing is your team. Because your team is operating day to day, they are having the more knowledge and more strength to find out the problems and find out the solution. So we have formed one project, is called Saksham, that is community of interest. Community of interest is the concept. We have made the team from the different station, boiler COI, turbine COI, transformer COI, switcher COI, BOP COI. These COI are interconnected online. Whenever there is some problem, we have developed one chatbot. This chatbot fetch the data from the history till now, whatever the problems happens, on that basis, immediately you will get the answer. Suppose some station having the problem of some BTL. In which area BTL, they can write down the chatbot. Chatbot can immediately answer all the, till now, all the BTL where was happened, in which area, how much time taken, what was the root cause. Second, there is icons are there, the domain experts, as the CUI experts. They can click there, they can start interacting. They can provide them some suggestions. Now you do this like, because the scenario is changed. So earlier, maybe you have done at that time when the unit was running at the base load operation. Now there's a flexible mode, so analysis will be a little bit different. You have to take address operational regime plus also quality of the materials. Maybe required to, when you procure the material, that can be upgraded to take care of all these changes. And third thing we have developed is taken the initiative with Project Samarth. To take care of all this, you need your in-house manpower upgraded. Capabilities should be upgraded. For that, a number of training programs on fundamentals, on AI and ML, on coding system, we have provided to our engineers so that they are up to that level. Whenever something requires, they can develop the models, make it more intelligent, suitable to your requirement, suited site. So all these concepts helps a lot to improving the performance, improving the reliability, improving the safety in our company. Touchwood, Haldia is our power plant, which is from last financial year to till now, #1 in India in the PLA basis, 0 force outage till now. Thank you. Thank you very much.
So last question, sir. Sanilji, from a overall, I know you're from Adani and PTCL. You've been there managing the larger assets part of it. Now at Integrate, we talk about varied assets. With BESS, you have transmission assets, you have renewables. What is something you aim at to look at? I always remember your coined words, NOC, Network Operating Center. Can you just brief about, what's your idea about it and, how it is that going to help out for most of the customers in India?
Yeah, so the Network Operations Center is a concept which we first started when we were in Sterlite. I think at that time, Power Grid also was building one for the transmission assets. That was somewhere in 2014-15. First, we established that at Bhopal. Then later on, it was acquired by IndiGrid. Now it's shifted to Delhi. Parallelly, I think for a year I was with Adani. There also we set up, and now it is full-fledged. So the idea of NOC was to bring all the controls to one central control center, so that the substations can be controlled remotely. There were multiple things why it was required at one point, because one was the manpower at the locations. It was very difficult to find really experts at site. So if you bring the data to one place, if you bring the controls to one place, it's easier to manage, number one. Second is the knowledge remains, centralized knowledge gives you more advantage of understanding the behavior of the equipments. So along with the controls, you're getting a lot of data to the central control room, and that gives you a lot of understanding about the performance of these assets. For this, what we have done in IndiGrid is the transmission assets, the substations are being remotely controlled now. Whereas the solar power plants, which we have a small power plants of 5 megawatts to 300 megawatt size power plants. They are not being remotely operated. We are remotely monitoring them. Because again, solar power plants require very less intervention. They start up on their own and then shut down on their own when the evening comes. So there we are more involved in the monitoring of those assets, monitoring of the inverters or in other components of the plant, so that we can get the maximum out of it and then improve upon the generation from the plants. The battery storage assets we are directly controlling from remote. We have a battery storage plant in Gujarat. It is an Sanand, and we operate it from Delhi. This is our strategy, that we will be operating all our battery storage projects from Delhi. We have 3 more coming up, one in Rajasthan, another 2 coming up in UP. Again, the benefits are that, one, you get a central view of the whole assets. Second, you get the data so that it all consolidated at one place. And also, you can have, see, as a backup, we definitely have engineers at site. If this link, one big problem that comes up is the links. Today, we are much better. 10 years ago, we did not have this kind of a data, transfer capability at all. The first project which we did, I think that was the biggest challenge we faced. We could not get even kilobytes of data from the site to the central Mumbai. We were operating from Mumbai at that time. So today, it's much ahead of that scenario. We are able to gather the data. But if the data gets cut off, we do have backup. The backup staff at the plant can operate the plants. So this is how we are managing today. And our ambition is to put a layer of AI and analytics on top of that. I would not say AI, because these are various databases separately. Like if you heard the Mr. Dhawan from IES, what they were saying is that the data could remain in pockets, but ultimately somebody who can talk to those pockets of data and gather the information and make sense out of it. That's what we want. You cannot bring everything to one place, everything to one database. That will be a disaster. So that's what we are also trying to do. How we can bring all the pockets of data and bring into the management dashboards, so that we can also predict. IndiGrid is an InvIT. We almost guarantees the returns to the investor. We have given guidance of this much. This would be the dividend paid out in this year. So it's important for us to maintain the assets with that reliability and the performance of the assets. So that's what we are always trying to do, how to make more sense out of the data so that we are able to proactively manage the assets.
Thanks.
Thank you, sir.
I think,
one point.
sorry, we just have 6 minutes, Praveen. So.
Sure. Only one point to summarize. I think, Mr. Sanil, I could see that vision of creating that NOC. I'm pretty sure, when you talked about connecting the data sets at a lowest KBs to the highest speed of a data sets, is definitely now, the vision is through. That's great. Thank you. Alok, over to you.
Thank you. Yeah. So we now have 5 minutes left instead of 6. So just need you to talk about challenges and issues. Simply outline them. I don't think we have time to discuss. Mr. Srivastava does need to be done by 12:05. We started the session a bit late, so we have about 5-6 more minutes. So I just request you to do it in a minute and a half. Challenges and issues.
So I'll talk about the challenges which is there. I'll not go into that. One is the data quality has to be it's very challenging. System integrations, all the system has to be integrated. Legacy assets, which are old assets, how we can bring out in this scenario. Cybersecurity is one of the aspects which is really important when you come to installations. Interoperability and vendors to bring it into lock-in in this area. Then AI explainability, then skill development to see that our whole staff there is skill gaps should be, cope up. You will see that there is a change management should be there in your whole team, not only from the top management to the technician level. You have to see the communication is also available. The communication network is very important for any distillation. Then human dependence on automations. That is one of the aspects which these are the challenges. And above that, which I always say, there is a drift because we are drifting from mobility. We are putting it from the normal legacy to the distillation that is to be. These are the challenges I feel out to be.
Mr. Singh, same question, same amount of time to answer.
In my opinion, cannot call challenges opportunity. Opportunity are there is the infrastructure, because the infrastructure is the most important for carrying out this digital transformation or digital change. The infrastructure may be from the your server, your IT, your IoT system, sensors, and above all is your manpower. Have trust on your team. Give the platform, give the opportunity to work on this. Don't rush on the market, because the software which are available may be not suitable to you. So with the help of those softwares, first enrich the knowledge and capability of your team. I'm sure the team will develop a number of new ideas. Those ideas can easily give the return with the time. Thank you.
Thank you, sir. Mr. Mishra.
My perspective, the challenge we found, which is beyond our control, that is how the whole ecosystem can be helped through the digitization and AI. Because starting from the inception of whether it's a power plant or manufacturing plant or a mine, whatever it is, the whole approval process which involves government, and down the line when you operate, how the involvement with the government, like the peer-to-peer transmit of electricity, the example he given, if that kind of system is developed, because ease of doing business is paying a lot of burden on all the companies. So if that can be addressed by of course it is being done by the government, but it's very slow pace. If that can be addressed, that ease of doing business and the ecosystem is made more conducive, then that would be better. That is the biggest challenge what we see in the present context.
Thank you. Mr. Namboodiripad.
So I don't want to repeat whatever has been already said. Only I would just like to add, any project, AI or analytics project, will be successful only if you have two sets of people working together. That is, the subject matter experts have to sit along with the IT team plus the manufacturers like Praveen. Otherwise, the system will fail. I have seen it failing. I've seen it successful also, where we had a good team. It was a very successful project which came out, where we could analyze the power plant's failures. Even a failure in a bearing, we could capture it before the bearing failed. That gave us a huge advantage, because we had a very nice team of subject matter experts as well as the programmers. So that's what I would say. That is where many of these projects fail. So take that into consideration whenever you are doing a project.
Okay. Thank you very much. I think we've covered a lot of ground in the last 60 minutes or so. And for that, we owe gratitude to Dr. Srivastava, to Mr. Singh, to Mr. Mishra, to Mr. Namboodiripad, and to Mr. Jadhav as well. So big hand for all five of them. And we do have, I think, some group photograph and mementos. So I think Mr. Jadhav is the one who's going to be presenting this. So Mr. Jadhav, if I can request you to please first present it to Dr. Srivastava. Dr. Srivastava, and I think there's a memento as well. And I'll have that. Thank you. And then to Mr. Singh, please. Sir, thank you. And to Mr. Mishra, please. And yeah, yes, please, yeah. Thank you. To Mr. Namboodiripad, please. Thank you. And yes, please, yeah, group. हाँ, थोड़ा जल्दी कर दीजिएगा. Okay. Yes. Thank you. Thank you. Thank you. So just one, I'll just make one announcement.